Hi, my name is Munawar, and today we are going to solve problem 14.3 from a book Structure Analysis by R.C. Hibbeler, 8th edition. First of all, we go to File from ETABS software file, New Model. Then there will be a small window will be appear in which we will set the units. Our model is basically in FPS system, so we will select US customary units and hit OK. Then this window will appear. Now we will decide the grid spacing between X and Y direction. In ETAB software, we basically work in X and Z direction because Z is the vertical axis. So here I am deciding the spacing according to my problem. In X direction 3 feet and in the Z direction 4 feet. Okay, then within a few seconds the grid which we have model will be displayed in 3D and in the plan view. Then we will work in the elevation by clicking elevation first on the first grid here. Now we can see the horizontal distance is 3 feet and vertical height is 4 feet. Now I am drawing in the truss members as we have given in the problem. At this joint there is no support. I am removing the support, and at the upper right side is a hinge support, so that's why I am assigning. Now I am going to define the material and cross sectional properties. First of all, the material. In our problem, the modulus of elasticity is 1, that is given in our problem, 1 kip per feet square. So I am, for the easiness, I am going to convert the units into consistent to make to according to our problem here. Now I am putting E is equal to 1 and modulus of elasticity 1 kip per feet square. And now I am going to define the cross section whose cross section area is 1. I am selecting a rectangular cross section area. Here I am assigning its material property, and now I am defining its depth and width, which will after multiplying becomes A is equal to 1 feet square. As stated in our problem, A is equal to 1. Hit OK. Now I am going to assign the members which I have defined. A is equal to 1 feet square whose modulus of elasticity is E is equal to 1. Here I am going to assign a joint load minus 2 because our load is acting downward in our problem, in the downward direction. Now apply OK. Load pattern, because it's an ELSA problem and self weight of the member is not considered in the ELSA problem, in this analysis problem. So now I am going to solve the model. Before the running of analysis, I am releasing the moments at the start and the end nodes. Here, now all the members will act as the axial member. Now I am running the analysis. The form shape, their load applied here. Here we can see the displacements in the x and y direction in the free node. At where we applied the loads, the x direction is 4.5 and in the vertical direction is the 19.5. So here is it, 4.5 and 19, which is exactly the same, almost exactly the same as we did in our numerical problem. So here are the reaction, minus 1.5 q3 in the negative direction, and other two reactions are positive. Apply. Here we can see our reactions as given in our problem. So now at the end we will study the axial forces. Axial forces minus 1.5 a compression and 2.5 tension in the inclined member. So here we will see the member forces, axial forces applied. I am showing the values. Okay, here the tension force is 2.5 and the compression force is 1.5. That's all. Thank you.